You all can see the screen, guys, right? Ashlesha, Ashutosh, Unar, and Yash.
Yes, sir.
So you know that
Yes,
guys,
sir.
we are starting with a new chapter in statistics, that is correlation. Now, guys, when we want to know whether two different variables have some relationship or not, and if the relationship exists, then how strong that relationship is. And why do we want to know the relationship? To understand cause and effect relationship. If the relationship exists, then one of the variable is cause and the other one is effect. For example, price and demand of a commodity. They have very strong relationship and the relationship is negative or inverse. When price of a commodity goes up, its demand goes down, right or not? And when price of a commodity falls, its demand rises. So here price is cause and demand is effect. So to establish such cause and effect relationship, we require correlation, not only in economics, but in various fields of our lives. It may be part of physical science, it may be part of social science like economics. Have you understood what I said all? And there we use correlation. So to know, okay, there are various variables which have some relationship where one variable depends on the other and acts according to change in the first variable. Correlation is used to determine whether relationship among two different variables exists. Am I clear? So correlation is used to understand whether relationship between the two variables under one's study exists or not. If the relationship exists, how strong it is, and to establish cause and effect relationship among the variable for further study. For example, we know that demand of a commodity and its price have very strong relationship. The relationship is negative or inverse, where upon rise in price of a commodity, its demand falls and vice versa. I hope you're understanding everything, guys. Right, Ashutosh, Hunar, Ashlesha, Yash.
Yes, sir.
I'm asking all guys.
Yes,
Yes,
sir.
sir.
Good. Note down this much, guys. Here, price of the commodity is cause and demand is the effect, or change in demand is the effect. Right, guys? To establish relationship, we calculate correlation coefficient, which is presented as small r, right? It is presented as small r. The value of r ranges between -1 to +1, including both the extremes, that is -1 and +1. What I'm trying to tell you guys is that value of r, that is correlation coefficient, can never be lesser than -1, can never be more than +1. Am I clear? It ranges between -1 and +1. If it is close to 0, it means the relationship between the two variables is very weak. If it is 0, the relationship does not exist at all. Am I clear? If it is close to 1, the relationship is very strong. If it is close to +1, the relationship is positive, that is direct, like relationship between hard work and good marks. More the hard work, more or the better would be the marks. Or relationship between supply and price of a commodity. When price rises, supply also rises. When price falls, supply also falls. Am I clear? Or the relationship between temperature and power consumption. More the temperature, more is power consumption. And if the value of R is negative, then the relationship is inverse. Means with increase in one variable, the other variable decreases, and vice versa. Have you got me, guys, or not? I'm asking those who are online.
Yes, sir.
Yes, sir.
When start noting down this, guys. Start noting it down here, guys. All this is what I have already explained you just. Now, guys, in this chapter, we are going to see two different coefficient of correlation. One is Karl Pearson's correlation coefficient, and other is Spearman's rank correlation. Starting with Karl Pearson's correlation coefficient. What is correlation coefficient? That I have already explained you guys. So the value of R here is summation dx dy upon summation dx square or summation dx dy upon square root of product of summation dx square and summation dy square. I hope you have got this, guys. In numerator, we have summation dx dy. In denominator, we have square root of product of summation dx square and summation dy square, where dx is deviation of x is our one variable with its actual mean, and same as dy, that is deviation of y with its actual mean. So this formula we use only when we want to consider actual mean. We will see one more formula where without calculating mean, you can find correlation coefficient with assumed mean. Have you got me? Note down this much. All. So here it is x minus x bar. 1 minute, guys. And here it is y minus y bar. I hope, guys, you all have noted down this, right? So this is the data of, guys, monthly income and monthly savings of 8 families. So we have to find relationship between monthly income and monthly savings, where we take income as variable X and savings as Y. Since the data given to us here is in multiple of 1,000, that is everywhere three zeros are there, that we can ignore. So I'm writing income as 20 instead of 20,000, then 30, then 40, then 50, then 60, then 75, 85, and 100. Have you got this, guys, or not? Ashlisha, Ashutosh, Hunar, and Yash. I'm asking everyone, guys.
Yes, sir.
Yes, sir.
So whether we take the absolute data or the data like this, the value of R would be same. Here also 2, 4, 7, 6, 8, 10, 8, and 20. So here summation X is 50, 40, 90, 140, 200, 275, 280, 360, and 460. N is, that is number of observation or number of families are 8. So summation X, sorry, X bar, that is mean, would be 460 divided by 8, right? That is 230 and 115, and half of 115 is 50 and 57.5. The same I am doing for savings, the other variable. 6, 7, 13, 19, 27, 37, 45, and 20, 65. The summation Y here is 65. N is 8. So Y bar is 65 divided by 8. 8.125. Now dx. That is deviation of each of x with its mean. That is x minus x bar, or x minus our x bar, that is mean is 57.5, right? So 20 minus 57.5 is minus 37.5. Then 30 minus 57.5 means minus 27.5. Then minus 17.5. Then minus 7.5. Then 60 minus 57.5 is 2.5. Then 17.5. Then 27.5. And then 42.5. So guys, I hope what I did here, right? Ashlisha, Hunar, Ashutosh. The same way we will calculate
Yes, sir.
dy, that is deviation of each of the y with its mean, that is y minus 8.125. So 2 minus 8.125 is minus 6.125, then minus 4.125, then minus 1.125, then minus 0.125, sorry, it is minus 2, then 10 minus 8.125, that is 1.875. Then again minus 0.125 and then 11.875. Is it clear, guys, to all? ये वाला 10 minus 8.125 आप खुद बताइए क्या आएगा. Then dx and dy means product of dx and dy. That is minus 37.5 into minus 6.125. That is 229.6875 and positive. I'm taking only up to two digits after decimal. Then minus 27.5 into minus 4.125. That is 113.44. Again in positive. Then 17.5 into 1.125. 19.68. Then 7.5 and 2.125. 15.94. And so on, guys. This will come in negative. This is also in negative. Am I clear? Are you getting this? Now dx square, that is square of 37.5. 1406.25. And the square of 27.5. 756.25. And the square of 17.5. 306.25. Square of 7.5. That is 56.25. Square of 2.5. 6.25. Again 17.5, 306.25, 27.5, 756.25, and 42.5. Square of it is 1806.25. And then dy square. That is square of 6.125. 37.51. And the square of 4.125. 17.01. Then 1.125. Square of this. 1.26. Then 2.125. Square is 4.51. Then 0.125. That is 0.01. 1.875. 3.51. 0.125 we already taken, that is 0.01. 11.875. 141.01. So now here we have summation dx. That is sum total of all these. That is 27.5 plus 27.5 plus 17.5 plus 7.5 minus 2.5 minus 17.5 minus 27.5 minus 42.5. That is 0. Okay, but guys, we do not need to calculate this because we do not require summation dx anywhere. We require summation dx dy, summation dx square and summation dy square. The summation dx dy is sum total of these items. That is 229.68 plus 113.44 plus 19.68 plus 15.94 minus 0.31 plus 32.81 minus 3.44 plus 504.68. That is 912.48. Now summation dx square. 1406.25 plus 756.25 plus 306.25 plus 56.25 plus 6.25 plus 306.25 plus 756.25 plus 1806.25. That is 5400. And summation dy square is 37.51 plus 17.01 plus 1.26 plus 4.51 plus 0.01 plus 3.51 plus 0.01 plus 141.01, that is 204.83. Now we will use the values in our formula of correlation coefficient. The summation dx dy is 912.48. Summation dx square is 5400 multiplied with summation dy square, that is 204.83, and the square root of this. So 5400 into 204.83 is 11,06,082, and the square root of this is 1051.7. So 912.48 divided by 1051.7 is 0.86. Means the relationship is positive and strong enough because it is close to 1, positive 1, and relationship is direct. Have you understood, guys, or not? Hunar, Ashlesha, Yash, Ashutosh, Aryan, have you understood this?
Yes, sir.
Yes, sir.
Note down the data, guys. You all noted it down till here, guys, right or not? Everyone, right?
Yes, sir.
Now, guys, with this formula of R, you must understand one thing, that an exam, it would be difficult for you to calculate these higher values, especially CBSE students who are not allowed calculators. And that is why the better one would be the one with assumed mean, right? We will see that in our next class. You know that the formula that we saw today is with actual mean. Done, guys, right? Those who are online, noted down everything till here.